Yeah.
Bonsoir.
مرحبا، يعطيكم العافية.
Bonsoir, Monsieur Dakash.
يلا 2 minutes بس I'll wait 2 minutes just for the others to join. يلا 1 more minute and I'll start. Okay. I will start my presentation. Thank you for joining. It's our second week within the series of webinars covering many topics in the ICT. Last week we did robotics. This week we are doing Arduino. I believe it's a challenging skill and the chapter we are doing, since we as ICT teachers we don't have all the electronic skills in order to attend it, but from my experience we can do it easily, since we have advanced coding and algorithm skills. That's why it is a challenging session for today, and I hope at the end of this session you will see that it is feasible even to make a part of this session online, since it's known that Arduino, we need electronic components like you are seeing here. So we have electronic devices, and the main question is, how can we do it with our students? Since there is a theoretical part that we should introduce to students, that's why I believe that it is doable, and hope will be back to school very soon, so we can once at school attack the practical part. So I'll launch my presentation. So I believe now you are seeing the PowerPoint presentation.
Yes,
Yes.
Great. So it's about 70 slides. And of course, if after 40 minutes I didn't get the professional version, I have it, but I don't the time to send you the link from our office at Dar al-Warraq. So if after 35 minutes it will be cut, so I'll ask you to join again. Mr. Muhammad Noor from Dar al-Warraq.
sorry.
Yes.
Yes, I have a question. Mr. Can you send these PowerPoint files after the meeting privately, more than the session, for the session? Only the also these, so we can revise it after the meeting.
Yes. So it's 2010, 2020. Send PowerPoint presentation. Okay, great. So
Yes.
I was saying
The last
that,
meeting for the first one and for this.
for robotics and for code
Yes.
Okay, for sure. So I was saying that Mr. Muhammad Noor from Dar al-Warraq is present with us. So he is in Riyadh, and later on, if you need any support for specimen or other things, he can help you. So for the first slide, okay, Muhammad Noor is raising his hand. Muhammad, بدك تقول شيء ولا it's okay? Great. So today it's how to implement Arduino in our ICT curriculum. So we will explore all the tools we need to make the online Arduino a successful task. The audience mainly are ICT teachers, but of course, if we have, let's say, math or physics teachers, they can do it easily, since we are talking about science. At the end of this webinar, you will receive a certificate of participation. It's good for your profile, for your CV. The last session we did, I asked you to send on my WhatsApp your name to make sure that you participated, since there is few teachers who subscribed but didn't reach the webinar. So each person sending his name by WhatsApp, he is declaring that he follow this session, so he will receive a certificate of participation. In order to receive the certificate of participation, I ask you to send on WhatsApp. You can do it right now or at the end. your full name with capital letter, how it should be on the certificate, your school name, and your email. Why Arduino in the ICT curriculum? Since ICT is considered as a science, as we know, to be delivered to students from grade 3 till grade 12, and since Arduino is in direct link to STEAM education by building project and linking all the science, technology, engineering, art, and math together. So it's the good tool to implement in the curriculum. Of course, here we will see that it is linked also to what we call the IoT, Internet of Things, and the artificial intelligence and the machine learning. It's an introduction. It's the good introduction for students to know better what is IoT, what is artificial intelligence, and what is machine learning. So since ICT is considered as a science, in addition to algorithm coding and robotics, microcontrollers is a major skill that should be delivered to students. And we cannot see the ICT without this chapter called microcontrollers. Now, for which grades we should introduce microcontroller? First of all, let me tell you that there is many brands of educational microcontrollers we can see on online platform, on YouTube and other, but mainly we have two major brands, the microbit for grade 4 to 6 that we integrate, and later on for grade 7, 8, 9, and Arduino for grade 10 to 12. I don't know which week, but soon, I guess next week or the week after, we will be attacking microbit in order to see what is this microbit microcontroller dedicated for grade 4 to grade 6 or to grade 9. So today we are concentrating on the Arduino grade 10 to 12. And in our curriculum, right-click that you are using, most of you are using, you will see that in grade 10, 11, 12, you have the Arduino chapter. Hope that all of you have the updated version. And in case in grade 10 or 11, you don't have Arduino, this means that you are not using the updated version. So please, I ask you to contact me or to contact Mr. Muhammad Noor. I'll send you his contact at the end of this session in order to solve this problem. Now, why microbit? Since microbit, it is developed by the BBC, the British company, and it's adopted by Scratch and by Microsoft. So once we reach very soon microbit, you will see how much it's important when a software, or sorry, a hardware is linked to two important company in programming like Scratch and Microsoft. Here we can see that in Scratch there is an extension for the microbit, and here we can see that MakeCode made by Microsoft also has developed a software to program MakeCode. So it's not about Wissam Dakash, me, that I'm saying that it's very important microbit or it's very important Scratch. When you see that major companies in the field of coding education are adopting microbit and not other microcontroller, this means that it's the most important microcontroller ever. And for Arduino, there is no direct link if you want to with such the microbit, but if you see that in major universities, all students are using Arduino to build projects for, concerning IoT and other skills. This means that it's the first microcontroller, and it was the first educational microcontroller to adopt what we call the open source platform, and many other copied this technology. Why Arduino? Since the hardware is cheap, it is available on AliExpress and other online platforms like Amazon and Souk, and there is many educational resources that you can find easily on YouTube and on other websites. The hardware is cheap. Look here, the Arduino board with the cable, it's about 1.86 to 3.76 US dollar. You can see that the hardware is available on AliExpress. All you need to do is to type Arduino sensors and you will get a list of sensors, and you can see that the prices are really down. If you go to on YouTube and you search for Arduino educational project, you will see that there is hundreds of projects already done, and you can explore. Now, the major problem is not how the students will acquire this technology. The major problem from the trainings I did all over the world, in Saudi Arabia, in Egypt, in Morocco, in Lebanon, online, the major problem is how the teacher can understand this technology, since, as we said before, it's really new for the teacher, talking about sensors and resistors and jumper wire and breadboard and so on. That's why the main target for this webinar is to make it easy for you as teacher. And once you are confident, you will see that you can teach it. And as you will see, I will not make the bar really high for you. I will make it really low in order to make you feel confident and secure, and to start teaching this technology with the kids. And believe me, if you will do it in the way I'm doing it right now, you will be confident. Your students will understand very well why they are learning Arduino. The idea is not teaching Arduino to teach. No, it's not the way. Teaching Arduino has very many goals that we will discover very soon. So start teaching Arduino. If you are at school, now it's not the case, but if you are at school in a computer lab, each 2 to 3 students must be working as a group together. So you will make them in a group of 3, but now, and teaching Arduino is divided into 2 parts, the theoretical part and the practical part. The theoretical part means to understand the concept, the environment of Arduino, and this is the most complicated and the most important. And after that, building projects will be really easy. You can find many resources. We can support you. There is many idea, many projects in the book to start working with this technology. But the idea is how to understand the environment of Arduino. This is the most important. And then after, the theoretical part consists on what? On explaining the concept of microcontrollers in real world. What is a microcontroller? Those are big questions that you should ask to yourself and to your students. To introduce Arduino as hardware, to introduce Arduino as components, and as software. So, and the practical part consists on creating a real project with Arduino hardware. developing the coding part to make the hardware operational. So let us focus on what we did till now. We are saying that Arduino is divided into two parts. There is a theoretical part that we can do it online easily. And there is, and I already did it with my student, it gives a great results. And the second part is the practical part that should be live at school. So the main question, should we do the online part, or shall we wait till going back again to school to do both? I advise you to start online. It's a great experience, and to make sure that students assimilate those concepts by giving them a few quizzes and questions later. And later on, I can provide you ideas about what kind of questions you can ask for students in order to make sure they acquired those skills. And in case one day we are back to school, so you can attack the practical part. So since you are teaching online, how to solve this problem? The idea is very simple. You can easily teach Arduino from home by following a clear and practical concepts. So before starting this chapter, I mean, if you are planning in 2 weeks to start or in 1 month to start the Arduino chapter, I highly advise you to send them those two links. You will have the full PowerPoint, but by the time being, I will send you those two links in the chat. You can keep them. Those two videos are a really clear introduction to what we call yeah, Asil, yes, tell me. Asil, you raised your hand. I asked you to unmute. Asil. Okay. Okay, so I will continue. So those two videos are, of course, there is others, but I choose those two videos because they are really clear and they give an idea about what is IoT, the Internet of Things, and that day after day we are approaching to this world of Internet of Things. Today we have Internet of People, so we are using internet so we can communicate between each other, but objects cannot really communicate in order to create a better world, interactive, more intelligent. And so using those two videos and asking your students to watch those two videos before starting your Arduino, it's very important. It's very important for you to simplify this task. So, and also before starting this lesson.
Excuse me, can you hear me?
Yes, yes, I'm hearing you. Tell me.
I'm sorry, I have mic options. I just want to tell you, I already taught Arduino with the girls, and for the simulation, I'm using a program, online program, and all the girls can open it. It's named Tinkercad. They can open it, and it's just like in real. They can use
I know,
wires,
I know it, but is it real? Is it free?
Yes, it's free.
The software is free. You can simulate free.
Yes, free. It's online website, and we don't need to download any program. It's online
great,
website.
Great. It's good to know. I will check it, and we'll give you feedback later on. Thank you for the remark. It's amazing.
Thank you.
So then before starting the session, you will also, after watching those two videos or other videos that you can select, of course, you will ask them to make a PowerPoint presentation in order on IoT, in order to give the definition, where IoT is applied, and it consists on which concepts. So after watching those two videos, students will find easy to make this PowerPoint, and you will have students really ready to start understanding the concept of Arduino. So then after, or this is aside, the software you need, there is people who are asking to access. So the software you will need till now to work on Arduino, I send you also the link, and it's the Arduino software and the fritzing software. I'll talk about fritzing later on. So now we are in a practical lesson, and you will see that there is lesson 1, 2, 3, 4, 5, 6. In order to start at least 6 lessons and to have the feedback of those lessons. So the first lesson, it consists on general questions and answers. So students are well prepared to start lesson 1 with confidence. So you have to start, you as teacher, to review the notions of computer with the input-output devices. So you will ask student about what are input device, what are output device, and you will wait for answers. What we can connect directly to a computer. So of course, they will tell you printer, scanner, mouse, printer, and so on. And then after, you will ask the question, is it possible to connect a lamp or a LED? Is it possible to connect a light sensor, a temperature sensor, an ultrasonic sensor? Is it possible to connect a pump, a water pump, or a motor? Of course, the questions will be, no, I can't, but of course I can connect the mouse, printer, and so on. From the above questions, students can conclude that they need a special setup in order to connect the computer to the external world. And here I think that by seeing the videos and by asking them those questions, they will be more and more ready for attacking this lesson. Another set of questions, students are asked to define a robot. What is a robot? And after all, and from my experience with the students, a robot is an electromechanical structure that a user can program, not the manufacturer. The manufacturer can program a machine, but the robot, we as users can program a robot at any time to do different missions. And from there, we ask the second question: can we consider a washing machine a robot? For me, no, it's not a robot, since the user cannot change the functioning of this washing machine. Can we consider the lift in our building a robot? Of course not. Sorry. Then try to list a series of electronic components and ask your students if those components can be considered as robots, like the fridge, the air condition, and other devices. And of course, all the answers should be no, we cannot consider for the time being the machines that we are using everywhere as robot, since the user cannot program and modify the functioning of this machine. Then it's time for answers. It's time for you to give answers. So nowadays, you have to tell your students that most of the electronic machines are not considered as robots, since the user cannot program them and change their functioning. Example, you give this example and I will love it. Can the user program the fridge to count how many times the door was opened? Of course, no. But later on, we will have fridge. So we have 10 minutes, 10 more minutes. After that, I'll ask you to join again for another 40 minutes. A new set of questions will be asked for the lesson one. And as you can see, the first lesson will be like a dialogue between you and your students. You will prepare a set of questions. Once you as a teacher, you will watch many videos regarding the Arduino, regarding the microcontrollers, the IoT. You will feel confident and easy to ask those questions. So here, what is a microcontroller? You will give the answer. It is a word divided into two parts. Microcontroller. Micro, it means it is small, and controller, it controls. It controls what? We will see later on. Where we can find a microcontroller? So the answer is all microcontrollers are found in every and single electronic and mechanical machine. TV, radio, air condition, fridge, lift, all the electronic machine that you can imagine, there is a microcontroller, like even in the telephone or in the computer. Can we program the microcontroller of the washing machine? For the time being, of course, no. So we continue lesson one. We define a microcontroller, the electronic board that can link input and output devices and can be programmed using a coding language. This is the definition of the microcontroller, where we can find a microcontroller in every electronic device. Lesson one, you have a set of answers to provide to your students. Give the definition of IoT from what you saw from the YouTube videos. Okay. Since a microcontroller is the path to IoT, Arduino will make students understand and create simple projects. So now your students know about IoT, and you will tell them that if you want to explore more the world of IoT and create simple project with your hardware machine, and the interesting thing in Arduino that your students can buy alone components and devices from AliExpress, from Amazon, from Souk, and they can start building alone the projects. We as teacher, our simple mission is to put them on this track, to explain them what they can do, because alone they will be lost. Why? Because as I told you before, there is a lots of educational resources online. So the student will not figure out which resources are good for him to start. So you as a teacher, from an educational perspective, you will guide him and you will tell him what to do and what resources, software, projects he can do. So I believe that the first lesson is done. If you have extra time, you can ask them to see a video for an Arduino setup. So I'll jump to the second lesson, and in the second lesson, you will start by a quick review from the previous lesson. Even if it's oral, you can ask them a series of questions from the previous lesson, or you can prepare a brief document you can send them, and they have to fill it out in Google Classroom, in Meet, and other platforms. And then after, we will introduce the hardware components. So now the second lesson is to introduce and to understand more what is a hardware, what is the hardware we use for the Arduino. So first thing, we use the hardware the Arduino board that you can see in my hand and on your screen. We need what we call the breadboard. I'll explain later on what is a breadboard. The white object here where I have jumper wire and electronic part. I need also wires to connect the different elements of my Arduino project. I need LEDs to start the simple project. I need resistors, the push button, the sensors, and here I have many sensors available for Arduino. You can imagine you have more than 60 sensors you can choose to program and to make interesting projects. Then after the ultrasonic sensor to measure distance. Then after I have the LDR sensor that measure the intensity of light, and for the public light in the streets in the early morning they will turn off directly. It's because of this sensor. The moment they see light, okay, you can directly switch off a lamp. So and by the end of the lesson 2, you will ask your students to make a research for ideas of projects made with Arduino. So maybe you feel that this, comparing to lesson 1, that this this lesson is short. Of course, it's not, since you have to explain a little bit for each component the use, and you will have it in the other lessons. So I will not explain in detail in lesson 2 all what we need here for this lesson. Later on the following lessons, you will discover the breadboard, the Arduino board, the sensors, and other devices. So I will go for the third lesson, and I will start exploring the Arduino board. And of course, if it's your first time in discovering this electronic microcontroller, maybe you will feel that it is a little bit complicated. I'll tell you from now that it's not. We still have 2 minutes, so please, I will ask you to join at the end of this first session. So the microcontroller, it's true that we see that there is lots of component on this board, but actually we will need only a few of them. Asil, yes, can you ask a question before it ends?
Okay, can I ask a question? I told you I already taught the girls about Arduino, but I faced a problem with them, and we didn't finish the Arduino. I faced a problem with coding part. Yani it's very difficult for them, and everything simulation. They saw the Arduino and they understood everything about Arduino and how we can connect ultrasonic and whatever we have sensors. But
Okay.
the problem with them is yani how to write the code. I don't know. It's very difficult.
No,
For
no, no,
the
no.
girls
I
to
will
know.
explain. Asil, look, for the
Yeah.
code, for the coding part, they don't have to memorize detailed code for Arduino, since in the software you will have example of codes. All they need to understand is the concept, how to modify the program in order to make it or to adapt it to your project. And this is what we will see today. Of course, they have to know what we call the concept of the if statement, the loop, the variable, and I believe those concepts are acquired from Small Basic and from Python. But in Arduino, they don't have to memorize in detail how to write the program. I will end this session and I will invite you, please, to join again the new session. It will be cut in few seconds. Okay? Yalla,
Oh, okay.
meet you in few